Let's go to page 124. This is lesson 2.7, and this lesson is about proof angle pair relationships. So let's go and read through the paragraph. It says, sometimes a new theorem describes a relationship that is useful in writing proofs. For example, using the right angles congruent theorem will reduce the number of steps you need to include in the proof involving the right angles. So the theorem 2.3, right angle congruent theorems. It says all right angles are congruent. So a theorem, before you can use it, you have to prove it first. Once you prove it, then you can go and use it. Okay, so the proof is below here. Okay, so over here, the giving is angle 1 and angle 2 are right angles. So you have to prove that angle 1 and angle 2 are congruent. Okay. So first you start with giving. So angle 1 and angle 2 are right angles, so that's giving. Okay. Then that's all you have, right? So next thing you have to do is, okay, once you use up the information, the things that you're going to be using would be definitions and addition postulates and like substitution. Those are the things you're going to be using a lot. Okay. So in this case, you use the definition. So angle 1 and angle 2 are right angles, so therefore measure of angle 1 equal to 90 degrees and measure angle 2 equal to 90 degrees. And that's a definition of right angles, because right angles are 90 degrees. Okay? Then after that, you can use so since both are equal to 90 degrees, you can say that measure angle 1 is equal to measure angle 2. And that's a transitive property of equality. Okay? So you can say that it's a transitive property, or you can use substitution also. Substitution is fine. Okay? So that is also acceptable. So once they're equal, then they're congruent. Okay? So again, definition of congruent angles. Definition of congruent angles means if they're congruent, they will have the same measurement, and vice versa. If they have the same measurement, they are congruent. So from here, you can see that all the right angles are congruent. So now you can use that in your proof. Okay? So you don't want to go through this whole thing again. Now let's go to example 1. Okay, example 1, use the right angle congruence. So you can write a proof. So over here, you have the segment AB is perpendicular to BC, and CD is perpendicular to BC. So both of these are perpendiculars. So you want to prove that angle B is congruent to angle C. Okay? So again, first you start with giving. Right? So always a good idea to start with giving. Usually that will give you have a good start. Okay, the next step is, again, after that you're going to use definition. Again, when you don't have anything else to go on, try to use definitions. Okay? So you can say that angle B and angle C are right angles. That's a definition of perpendicular lines. When they are perpendicular, they form right angles. Okay? So again, when two segments or two lines are perpendicular, they form a right angle. So that's where this came from. So angle B and angle C are right angles, okay, because they're formed by perpendicular lines. So that's a definition of perpendicular lines. Then after that, since they're right angle, we just have these, right? So over here, so all the right angles are congruent, right? So you can see angle B is congruent to angle C. And so again, this is right angle congruent theorem. Okay? Now, if you don't remember the name, it's okay. You can just say all right angles are congruent. Okay, that's what it means. So you don't have to write the word for word. Okay? As long as you know the theorem, the concept of the theorem. So if you write all right angles are congruent, that's fine. Okay, because that's what it means. Okay, now let's go to more theorems. Okay, on page 125, okay, here's more theorem for your notebook. So theorem 2.4 is congruent supplements theorem. It says if two angles are supplementary to the same angle or to the congruent angles, then they are congruent. So what it's saying is that if two angles are supplement to the same angle, okay, then they are congruent. So again, if angle 1 and angle 2 are supplementary, okay, and angle 3 and 2 are supplementary, then angle 1 and angle 3 are congruent. Again, so in other words, says if this is supplement to that, this is supplement to that. If they are supplement to the same angle, then they are congruent. And it's same thing with for complementary angle. Okay? If two angles are complement, to the same angle or to congruent angles, then they are congruent. So again, if this is complement to that and this is complement to that, since both are complementary to the same angle, then they are congruent. Okay? And so again, you can say that, or you can just use the name congruent complementary theorem. Okay? But for me it's better to just go and write out the definitions, saying that if two angles are complementary to the same angle, then they are congruent. Okay? But if you remember the name, then you can use the name. So either way is acceptable. Okay, so here is to prove theorem 2.4, you must prove two cases, one with angle supplementary to the same angle and one with the angle supplementary to the congruent angles. And the proof of theorem 2.5 also require two cases. Okay, so over here they just prove one of the cases. So just prove a case of congruent supplement theorem. So prove that two angles supplementary to the same angles are congruent. So prove that when two angles are supplement to the same angle, then they are congruent. Okay. So again, here's a given. So angle 1 and angle 2 are supplements, and angle 3 and angle 2 are supplements. Prove that angle 1 is congruent with angle 3. Okay, so again, write down first is given. Okay. So once you use up whatever is given, and if you have nothing to go on, try to look for definitions. Okay. So right now, so supplement, right? So that means since angle 1 and angle 2 are supplements, that means measure of angle 1 plus angle 2 equal to 180. And same thing over here. If angle 3 and angle 2 are supplements, that means angle 3 plus measure of angle 3 plus measure of angle 2 equal to 180. So those are definitions. Then over here, again, you can use transitive property or you can use substitution. Either one is acceptable. Okay? So you can substitute 180 for that, right? So since this is equal to 180, this is equal to 180, then you can substitute or you can do the transitive. So if you do substitution, write down substitution, that's acceptable. Okay? So since both are equal to 180, so they're equal to each other. Okay? Then after that, you can minus measure angle 2 from both sides. So once you subtract measure angle 2 on both sides, you got measure angle 1 equal to measure angle 3. So that's subtraction property of equality. Okay? And then after that, since they are equal, then they are congruent. That's a definition of congruent angles. Okay? So if they are same measurement, then they are congruent. Okay? So you can do the same thing for all the other ones. Okay? Okay, let's go to the page 126. Okay, intersecting lines. When two lines intersect, a pair of vertical angles and linear pairs are formed. The relationship that you use in lesson 1.5 for linear pair is formally stated below as a linear pair postulate. This postulate is used in the proof of vertical angle congruent theorem. Okay, so here's a linear pair postulate. Okay, if two angles form a linear pair, then they are supplementary. And so if angle 1 and angle 2 form a linear pair, means they make it in. So two angles, when you put together, it form a straight line. So that's what a linear pair is. So if angle 1 and angle 2 form a linear pair, so angle 1 and angle 2 are supplementary, and measure 1 plus measure angle 2 equal to 180. Okay. So that's the postulate. Okay, now let's go to theorem. So theorem 2.6, vertical angles congruent theorem. Vertical angles are congruent. So that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Okay. So here's a proof below. Okay. Prove the vertical angle congruent theorem. Okay, so prove that vertical angles are congruent. So given angle 5 and angle 7 are vertical angles, you want to prove that angle 5 and angle 7 are congruent. Okay, so again, start with what's given. So angle 5 and angle 7 are vertical angles. That's given. And then after that, you say angle 5 and angle 6 are linear pair. So this is linear pair. And angle 6 and angle 7 are linear pairs. Okay. And so this would be differential linear pair as shown in the diagram. Okay. Again, something's very obvious, right? They form a linear pair. Okay. Then after that, then you can say that angle 5 and angle 6 are supplementary, and angle 6 and 7 are supplementary. And this is a linear pair postulates. Okay, that's from here, linear pair. Okay, so again, if two angles form a linear pair, then they are supplementary. Okay, then after that, then you can say since angle 5 is supplementary to angle 6 and angle 7 are supplementary to angle 6, so therefore angle 5 and angle 7 are congruent, and that's a congruent supplement theorem. Okay. So that's from the one from earlier, okay? Because if this is supplement to that and this is supplement to that, so if two angles are supplement to the same angle, then they are congruent. Okay, so that's what it says. So again, if you don't remember the name, just write out the fact. So that's fine. Okay. Okay, now let's go to the example 4. So this is the standardized test practice, okay, so, but this is something that is more like a review of that. You have to use algebra combined with the theorem. Okay. Okay. So which equation can be used to find x? Okay. Well, since if you know these two angles form a linear pair, okay, so these two angles form a straight line. So these two are linear pairs. That means these two angles will add up equal to 180. That means 32 plus 3x plus 1 will equal to 180. So 32, so answer would be B, right? So again, this plus is equal to 180 because they form they are linear pair. So they are supplementary angles, so they equal to 180. This is not correct because this is for complement. That's when they form, like a perpendicular line. Okay. This one is not correct because they are not equal. Okay, they are linear pairs. Okay. And this one kind of just doesn't make any sense anyway. Okay, so you can just use your definitions. Okay.